If the red supergiant star Betelgeuse were to explode right now, we would witness a spectacle like no other. The sky would be ablaze, and the night would shine as brightly as day. Betelgeuse is indeed on the verge of exploding, but astronomers aren't entirely sure when this will happen, whether it's tomorrow or in 1,000 years. It's also possible that the explosion has already occurred, and we just haven't seen it yet. Supernovae, which are explosions of massive stars, occur in our Milky Way roughly once every 50 years, but visible supernovae from Earth happen only once in several centuries. Betelgeuse, located about 640 light-years away, will likely be a Type II supernova, a particularly stunning event that can even be seen during the day. The explosion would be so bright that it could be visible even in daylight. Its sudden brightness would momentarily blind drivers and pilots, like a flash of lightning. People would need to be cautious, especially around dawn or dusk when the sun is lower, and the burst of light from Betelgeuse could hit them unexpectedly. This brief flash of light would only last a moment, but it would be followed by the appearance of an incredibly bright new point of light in the sky, resembling a new star. It would shine brighter than Venus and Neptune and could outshine the full moon, lighting up the night sky for weeks or even months. During this time, the stars near Betelgeuse would likely be invisible due to the overwhelming brightness of the explosion. While it's certain that Betelgeuse will eventually explode, the timing remains uncertain. Astronomers around the world are constantly monitoring the star, and even some satellites are focused on it non-stop. Any change, no matter how small, is immediately recorded. When the supernova occurs, astronomers and amateur stargazers alike will point their telescopes toward the event. Space telescopes like Hubble and James Webb would capture detailed images, while their instruments would detect a huge surge in brightness, accompanied by an increase in gamma rays and X-rays. Radio telescopes would pick up dramatic changes in the radio wave spectrum, and gravitational wave detectors, sensitive to even the slightest shifts in the universe's fabric, would likely detect the explosion before we can see it. In addition to gravitational waves, neutrino detectors, scattered across the coldest and most remote regions of the Earth, would also likely detect the explosion, as neutrinos are emitted in large quantities during a supernova. After the explosion, Betelgeuse will scatter enormous amounts of matter and energy into space. Its remains will travel across vast distances, but given the immense scale of the universe, it's unclear whether nearby stars would experience significant harm. Betelgeuse is the first red supergiant star in our galactic neighborhood to undergo a supernova, and we'll have the unprecedented opportunity to observe it with modern technology. The size and scale of the explosion will be a shocking and awe-inspiring sight, and astronomers will continue to monitor the aftermath for years. 4 weeks or months following the explosion, Betelgeuse will remain visible as a bright spot in the sky. Over time, its brightness will gradually fade, eventually becoming invisible to the naked eye. However, astronomers will continue to observe it closely using telescopes, analyzing every change, however slight. After Betelgeuse's explosion, a dense remnant will remain, either as a neutron star or potentially even as a black hole. It could also form a magnificent nebula like the Crab Nebula, which could persist for thousands of years, providing a wealth of material for research. Betelgeuse's life began about 10 million years ago, when it formed from a dense molecular cloud of gas and dust. This cloud was made up of material from older stars. As this cloud collapsed under its own gravity, it eventually formed a protostar. Over time, the protostar gathered mass and initiated nuclear fusion. Betelgeuse was not alone. Its formation took place in a star nursery, where many baby stars were created. During this early stage, Betelgeuse was likely much brighter than its neighbors. As a massive star, Betelgeuse had a shorter lifespan than smaller stars, quickly using up its hydrogen fuel. This rapid consumption caused Betelgeuse to shine brightly, likely being several times hotter and brighter than the sun. After its hydrogen supply was exhausted, Betelgeuse began to fuse helium into carbon and oxygen. It expanded into a red supergiant, its brightness continuing to increase as it shed mass in powerful stellar winds. By this point, its size had already surpassed the orbit of Mars, and its striking red color fascinated observers on Earth. An interesting question arises about the potential existence of planets around Betelgeuse. While the short lifespan of the star makes the possibility of life on such planets unlikely, we cannot entirely rule it out. Given the differences in star systems, we might be making an error if we assume that conditions on planets around Betelgeuse would be impossible for life. The transition of stars, even those that seem eternal, follows a pattern of birth, life, and death. The impending explosion of Betelgeuse is not just a dramatic event on its own, but also an opportunity for astronomers to explore the life cycles of massive stars and the broader cosmic processes at play. Studying supernovae like Betelgeuse provides valuable insights into the creation of heavy elements and the dynamics of stellar explosions. These explosions are crucial for dispersing elements such as iron, nickel, and other heavy metals throughout the universe, enriching the interstellar medium from which new stars and planetary systems emerge. During a supernova event, the core of the exploding star undergoes rapid and intense nuclear reactions, producing a range of elements that are expelled into space. This newly formed material contributes to the creation of new stars and planets, continuing the cycle of matter in the universe. The remnants of these supernovae, often seen as nebulae, can be intricate and beautiful, displaying complex structures formed by the shock waves interacting with surrounding gas and dust. The study of these remnants also aids in understanding the different types of supernovae. For instance, Type II supernovae, like the one Betelgeuse is expected to undergo, occur when massive stars exhaust their nuclear fuel. In contrast, Type Ia supernovae result from the explosion of a white dwarf in a binary system. Each type of supernova has distinct characteristics and contributes in unique ways to the cosmic landscape. After the Betelgeuse explosion, the material expelled will form a supernova remnant, which will evolve over time, passing through various stages that can be observed in different wavelengths of light. Initially, the remnant may be visible in optical light, but as it cools and interacts with its environment, its emission will shift to infrared and radio frequencies. Observing these changes helps astronomers understand the physical processes that drive the development of supernova remnants. Another significant aspect of Betelgeuse's explosion is its potential impact on the surrounding interstellar medium. The shock waves from the explosion could trigger the formation of new stars by compressing nearby molecular clouds. This process, known as triggered star formation, is an important mechanism for creating new stellar systems. As a result, Betelgeuse's supernova could influence star formation activity in its region of the Milky Way. In addition to their role in star formation, supernovae are crucial for measuring astronomical distances. The brightness of a supernova can serve as a standard candle to determine distances to galaxies. By comparing the observed brightness of a supernova with its known intrinsic brightness, astronomers can calculate how far away the explosion occurred. This technique has been instrumental in studying the expansion rate of the universe and exploring the properties of dark energy. Betelgeuse's supernova will also offer a unique opportunity to study the neutrino emissions associated with such events. Neutrinos are nearly massless, highly penetrating particles that are produced in large quantities during a supernova explosion. Neutrino observatories, such as the Superkamiokande in Japan and the Ice Cube Neutrino Observatory in Antarctica, will play a key role in detecting these elusive particles. Analyzing neutrinos from Betelgeuse could provide valuable insights into the processes occurring at the core of a dying star and deepen our understanding of fundamental physics. The anticipation of Betelgeuse's explosion has sparked significant excitement and preparation within the astronomical community. Scientists are developing new techniques and enhancing existing technologies to ensure they are ready to capture every detail of the event. This includes improving ground-based and space-based telescopes and planning coordinated observational missions to study the supernova across various wavelengths. Additionally, the explosion of Betelgeuse could serve as a natural laboratory for testing theoretical models of stellar evolution and supernova physics. By comparing observations with theoretical predictions, scientists can refine their models and improve our understanding of how massive stars evolve and die. This knowledge not only aids in the study of stars like Betelgeuse but also contributes to the broader field of astronomy, offering insights into the life cycles of stars throughout the universe. As we await the moment when Betelgeuse finally explodes, the anticipation itself drives scientific curiosity and progress. The explosion will be a testament to the dynamic and ever-changing nature of the universe, providing invaluable information that will be analyzed for years to come. The certainty surrounding the future of the universe is that the planets around Betelgeuse are becoming increasingly sweltering as the star expands. As it grows, it will eventually consume these planets, and if life ever existed there, it would be obliterated by the star's intense radiation. Betelgeuse is on the brink of its explosive end, which will happen in a fraction of a second. The immense forces and timescales involved in events like this are so mind-boggling that we can barely comprehend them. As Betelgeuse runs out of helium in its core, it begins fusing heavier elements such as carbon, neon, oxygen, and eventually silicon. This process accelerates, but each new fusion stage produces less energy. As heavier elements accumulate, the star becomes more massive and unstable. Eventually, it will collapse under its own gravity, and when that happens, the star will tear apart in an instant, releasing all its remaining energy in a massive explosion. The big question everyone is asking is, when will this happen and will we witness it? Betelgeuse is increasingly unstable, and all observations indicate it is in its final stages. However, how much longer it will last is still uncertain. Astronomers are closely monitoring the star using various telescopes and technologies, including the Hubble Space Telescope, the James Webb Space Telescope, the European Southern Observatory's Very Large Telescope, and the ALMA telescope in the Atacama Desert. These telescopes have revealed important details about Betelgeuse's chemical composition and changes in its brightness. Between the end of 2019 and the beginning of 2020, the star's brightness decreased by about 25%, which drew global attention and fueled speculation about its imminent supernova. Further studies suggested that the dimming was likely caused by a combination of factors, such as a massive dust storm ejected from the star and large convection cells on the surface that were cooler than the rest of the star, causing it to darken temporarily. A similar but less dramatic dimming event was observed in 2024, likely a direct result of the 2020 darkening. While these phenomena can be explained, they highlight how unstable Betelgeuse is and offer clues that it may soon explode, or perhaps has already done so. The crazy part is that Betelgeuse could have gone supernova hundreds or even thousands of years ago, but we won't see its light until 650 years later. Many people often gaze at the Orion constellation because it is one of the most famous and striking in the night sky. Betelgeuse shines on the shoulder of the legendary hunter Orion, who holds significant mythological importance in many cultures. In Greek mythology, Orion is a mighty hunter, adored by Artemis, the goddess of the hunt. His image in the sky symbolizes strength, bravery, and a quest for adventure. Betelgeuse, with its distinctive red hue, has long captivated our imagination, inspiring countless stories about gods and legends. When Betelgeuse eventually detonates, Orion will be forever changed. The brilliant star that once watched over us as a protective beacon will be replaced by a brilliant supernova, and eventually by darkness. This loss of Betelgeuse will serve as a poignant reminder that the universe is in a constant state of change and transformation. What has been with us for so long will soon be gone, leaving us to reflect on the transient nature of the cosmos.